Hi everyone. Today we'll have the third session on SI unit and unit conversion. The aim of this session is to go through the basic units which are commonly used in pharmacy and in science in general. And very important aspect of today's session is to learn how to do a conversion from one unit to another unit. And then we'll also learn what is the importance of having units and how do we quantify and how do we do the basic changes using powers and exponentials. If you have any questions, always feel free to email me. I'm more than happy to go through your questions. As usual, there will be other means to sending questions on the Blackboard. I hope that you'll find today's session useful for you. Okay, the first question which may come to your mind is why do we need to use units of conversion? So in science, we routinely make measurements to define physical quantities. So as this picture here, you can see, you could possibly have a volume. So you could have beakers, you measure the volume of maybe solvent or water to dissolve your drug. On here on the left, on the picture, you see there's a unit of length or electric current. So any number you measure doesn't have any meaning unless it has a unit or SI unit, International Standard Unit. And then once we mention or we state the number, and we say, for example, you generated um, 10, 10, 10 what? 10 grams, 10 moles, 10 meter, you need to be specific. So the way we specify or we give identity to the number is using a unit or SI unit. The physical quantities which we gonna be more interested are those just highlighted here. So the mass, kilograms, and the symbol is kilograms. This is often very commonly used, of course, the length, and then the time, temperature, Kelvin, seconds. We count. The idea of this is we have a standard unit, which we call SI unit. We use it to express those physical quantities. Don't worry too much about the sort of details, but I would expect that majority of people, if they know what is a mole is. So mole gonna have Avogadro's number of molecules, for example. So we need to know, we need to learn, okay, what a mole is, because you're gonna be pharmacists, you're gonna deal with quantities. What is the difference from kilogram and a meter or a second or in terms of the physical quantity? We're not into the uh, calculations or the giving examples from pharmaceutical calculations here, but we try to develop the mathematical skills which we're gonna need later on or throughout your study to apply for pharmaceutical calculations or later on dose conversions or in science in general. You may come across those quantities such as force, energy, pressure. These are actually based on what we call base units. So these are the base units. So for example, you have force Newton, and then you look in the basic units or the base units are kilogram meter per square second. And the same correct for the unit of energy, joules. You see it on a bar of chocolate, and you see joules. Then if you look carefully, that is actually the base unit. And the same for the pressure, and this is the base unit for those. No need to remember those, but the idea is we may need to change or convert from one form to another, and that's the idea or the aim of this session. So to make it easier and to avoid any mistakes, I would always suggest that we use the power, so 10 to the power of n, and these are the common ones we use in pharmacy. So let's say, for example, you have meter, 1 meter, 1 meter will equal 10 to the power of 6 of micrometer. Now I could say 1, 2, 3, 4, 5, 6 micrometer. And see the difference here is far easier. because you're less likely to make a mistake. So always just try to be familiar with this. Try to use the 10 to the power of 6. Is far less likely to make a mistake when you use this. So these are examples. You get nano 10 to the power of minus 9, 10 to the power of minus 6 when you get to micro, milli minus 3. Centi is just probably just 100 or 10. It's just easier to express it. But then it's more, if you make more than one step, it can be a bit difficult. Okay, so we've learned these rules, how to because we said with units always stick to this exponential 10 to the power of something. Sometimes you need to multiply or divide, and so you need to remember those rules which we come across the last two sessions. If they have the same base, which they are in this case, so let's say 10 to the power of 3 multiplied by 10 to the power of 4. The answer will be 10 to the power of 7 because I just add them together. If I do the opposite or the division, 10 to the power of 3 divided by 10 to the power of 4, that means 3 minus 4. So that means the answer will be 10 to the power of minus 1. And if you get a bracket 10 to the power of 3, and you get a bracket here, maybe 2, then you just multiply them together, 10 to the power of 6. But then what you could have maybe 2 by 3 multiplied by 3 and then to the power of 2. So you need to do them individually. So 2 to the power of 2 multiplied by 3 to the power of 2. When you have something like this, a to the power, for say let's example 10 to the power of minus 1, that means 1 over 10. Or 10 to the last one, 10 to the power of 0, that means 1, which is the case for any number. Any number has a power of 0, always 1. Remember this rule. This rule is very useful. That one, I strongly suggest that you just go through it and remember it. 10 to the power of minus 1 in this case is 1 over 10. 1 over 10 means 10 to the power of minus 1. Always remember that. Okay, these are general rules. Units should always be clearly stated. And I often see this when I mark exam papers. Really nicely done, nice calculation. The student did really well. They did all the steps. And the last step, which is very important, is they end up with the right answer, but they forget to mention the units. Really critical, because if you end up with the right answer, what's the point? Because you didn't mention the units. So if it doesn't have a unit, it will have a meaningless number. So you must always state the unit. The unit is essential because otherwise the number does not have any meaning. And the second thing we need to remember, be consistent with the units. So for example, if you are doing an area calculation of area, you can't say 10 centimeter multiplied by 10 meter or 10 millimeter and so on. We'll have to unify those. We'll have to make sure they have the same, because otherwise it's just the whole thing is wrong. Because you get 100, in this case 100 what? Meter or centimeter? If you put centimeter, of course you're assuming squared, if in this case, then that's wrong. Or if you say centimeter meter, that doesn't make sense. So that's why we have to unify. So you convert this probably to centimeter, or this side you convert to meter, and so on. So be consistent with the units.